Welcome to the chemical life cycle. In this section, we learn about the origin of materials, how we handle them, and what are the consequences of making products on the environment. This then is the chemical life cycle. When we consider the chemical life cycle, we must look at the production, transport, storage, use, purposing, repurposing, and recycling, as well as disposal of the goods that are made. In section 1, production, we focus on the raw materials and the process that is used in terms of converting the raw materials into our products. Raw materials can be classified in a number of different ways. Here we classify them based on their origins. There can be plant-based raw materials, there can be animal-based raw materials, and there are materials which are neither specifically plant or animal, but are being mined from our natural resources. If we think of a plant-based material, starch is one of those items. If we consider spray starch, well, that starch could have come from something like a potato, from corn, all of that being plant-based. If we consider animal-based, right now, some countries may be experiencing bitter cold, and persons may be wearing coats. Some of those coats will actually be made from animal skin, i.e. leather, or may contain fur. So fur and leather are examples of animal-based products or animal-based raw materials. When we talk about mining, we have the example of the Inagua salt, we have the example of crude oil. So raw materials can come from a number of different sources and they can be obtained in different ways. But whatever it is we're making, manufacturing, producing, we have to start out with something, the raw material. Once we have the raw material, whether it be from plant, animal, or mining, the raw material has to be obtained. And the process of obtaining the raw material can of itself generate waste as well as byproducts. So for example, if your raw material was corn, then you're not going to take the entire plant. Some of the plant is going to go to waste. That becomes your waste. Some of it that you're not going to use to make your primary product may be used to make a secondary product. That can be a byproduct. The raw materials then are going to be treated in a number of different ways. Some of these ways involve simply the physical breakdown, an example being when you convert an ear of corn into grits. What you're doing is basically changing the size of the particle. That's a purely physical process. On the other hand, there will be some chemical changes. Chemical changes is where you change the nature of the substance. Once we've done those physical and chemical changes, our raw materials are now ready to go on to the next level. And that next level is incorporating the raw materials into your product. Whether we're making an industrial product or we're making something to sell directly to the consumer. So, raw materials are going to be processed in physical and chemical ways to generate our industrial and consumer products. At each stage of the processing, we have the potential to generate waste as well as byproducts. Waste, even though it's not desired, will still have to be considered in terms of what is the overall impact of our product on the environment. When we're processing our raw materials, it's important to consider what resources are going to be needed and how those resources will impact our environment. If you're using a plant, in this case a factory, you have to consider how much land space is being used for that factory. And that land space then becomes dedicated for that particular purpose, meaning it is no longer available for residential or for agricultural purposes. So anytime we look at making a product, we have to consider what does it take from the environment in terms of the land space. For very simple products, the equipment need may be very basic. For more complex products, the processing may require substantial equipment. That means a large investment, but it also means considering what resources go into making the equipment, what resources go into maintaining the equipment. And in terms of using the equipment, what is the manpower? What human input is needed there? In addition to human input, oftentimes processing involves quantities of energy having to go in. Whether that energy is electric or thermal, power is needed. How is that power being generated? The generation of that power also is associated with producing waste and byproducts. What water is used? Your product may not require water when you're actually using the product, but in actually making your product, it can consume a small amount of water, a large amount of water. That again means that in making your particular product, that water, seen as a resource, is being used to make your product. That means that the water is unavailable for other purposes. Within processing, are you going to be contaminating the water? If you're contaminating the water or additives are going into the water, it means that that water is going to have a different effect on the environment from the original source water, which would not have had any additives or waste items. So whether we consider water, environment, power, equipment, land use, all of this comes back to what is the impact of your processing on the environment? What waste are you producing? Where is that waste going? How are you processing the waste? And what byproducts? There can be two types of byproducts. There are byproducts which you can then feed in and use elsewhere, and there are byproducts which have no particular use at the time, which means that either you're going to store them or release them into the environment or try and destroy them. And again, you have to consider what is the impact of all of this on the environment. So now you have your raw materials, you process them, you also have some of your product or your intermediate substances. If they're not directly going to be used or sent out for secondary processing, there's a consideration of storage. You can't just take your item and sit it out there. You want to preserve your item in optimal conditions. That means you have to have consideration of what the environment of storage is. At what temperature you're going to store it. If the temperature is not going to be room temperature or the temperature of the environment, then you're going to have to invest energy in terms of either keeping it at a temperature that's higher, i.e. warmer, or a temperature that's cooler, in which case we're looking at refrigeration, cooling systems, etc. What about light? There are some products and some raw materials that are going to be photosensitive. That means that you have to prevent them from being exposed to light. Humidity also can affect your product and your raw materials. So it's a storage consideration. You want to store your substances away from the effects of humidity so that they don't break down or react or are otherwise compromised. Some substances will actually undergo changes simply when exposed to air, an example being oxidation. And so you have to consider, can I leave my product or my materials in the natural environment, or do I need to have a protective atmosphere In other words, do I need to store them away from oxygen? You also have to consider interactions. If your product involves more than one substance going into it, will these two substances react, two or more substances, if you store them together? And if the answer is yes, then you have to consider the interactions, the chemical interactions between these substances. That means that you have to store them separately. Some commodities are particularly valuable even in the low processed state. That means that you have to consider the possibility of them being stolen in a large way. For example, copper in recent years has been stolen quite a bit because it is useful in a number of different ways. So how do you protect and secure your products? How do you protect and secure your intermediate processed products? How do you secure your raw materials? In addition to all of this, because of treaties and conventions that you learn about later, certain products carry with them international obligations. That means that the manufacturer is required to look after the substance in such a way that it isn't available where it shouldn't be. We have to make sure, as a manufacturer, as a producer, that our product is essentially under lock and key. An example of this is when we talk about certain prescription medication. These medications are considered controlled substances and are heavily regulated. They can't cross borders just like that. They can't even be prescribed just like that. They can't even be stored within the pharmacy just like that. So security obligations, whether it's at the institutional, national, or international level, these have to be considered when storing materials. So now we have our product. It's at the factory, it's at the manufacturing plant. But it has to get to the users. And so there's transportation. Now, if our product was manufactured for export, then import-export rules come into play. There are transboundary rules that dictate which substances can be imported or exported, which substances can be moved from country A to country B to country C. So international regulations come into play here when we consider how we're going to transport our materials. How are we going to move them from one country to the next? How is trade going to be facilitated? There are rules of trade, there are rules of import, export, there are rules of what is allowed to go across the ocean, what is allowed to be airplane bound, etc. So all of these come into play in consideration, and all of these are spoken about when we think about the chemical life cycle of a product. Within a country, again, there are considerations. What is the transportation network like? How are we going to move these items across land? How are we going to move it, particularly in the Bahamas, across sea? And are they appropriate to be transported by air? These questions can be answered by considering the chemical treaties and conventions and other treaties and conventions which apply to products and raw materials. We also have to consider what is the network available for the movement of these materials. So transportation has to be considered. And as you're moving items, you have to consider what would be the impact of an accident while transporting these materials. And again, rules come into play as to what facilities must be in place in order to protect the environment as well as general life from such accidents. These again contribute to considerations for the chemical life cycle. So we have our products. Considerations apply in terms of the use of those products. Some items cannot be used for certain purposes, and it's not because they will not work, it's because there are treaties and conventions in place which dictate you cannot use this product for this. You cannot use the product for that. For example, there are substances that can be made which, on the one hand, will destroy certain plants and can be used as pesticides. But on the other hand, we know that these same products will harm the environment by killing helpful organisms. And so, by international agreement, it's been said that these products will be tightly controlled or even reduced to the point that we will stop manufacturing them. So when we look at how a substance is being used or proposed to be used, if we've signed on to a convention or treaty, then that dictates what we're going to do in terms of use or non-use of a particular product. At the national level, again, there has to be an internal system that dictates what is and is not allowed in terms of the use of materials. And these regulations, whether international or national, have been developed to protect life, property, the environment. Another consideration as we look at the chemical life cycle is the amount of effort, the amount of resources, the amount of potential harm that goes into making the product compared to the lifespan of the product. Are we going to invest hundreds and thousands and millions into making a product that we use for maybe 10, 15 seconds? Possibly. We have paper cups, we have used plastic straws. These are used for minutes, and yet we have to do so much to the environment to make these substances, and then after we've used these products, how do we then reduce the impact of these products on the environment? So an important consideration when assessing the chemical life cycle of a product is to look at the costs of the input versus the benefits of the output. And how does our product affect the environment? How does making our product affect the environment? And what effect does our product have after we've used it? These are all considerations. So when we talk about the uses, we've taken our raw material, we've put it through a number of physical and chemical processes, and we have generated our products. Some products are going to be essentially industrial products. Others will be consumer goods. Industrial products can go on for secondary manufacturing. For example, if our primary product was sheets of copper metal or sheets of aluminum metal or sheets of iron, then those aren't going to be used by a consumer, by you or me, just like that in 99% of the cases. They're going to go on for secondary manufacturing. Your airplane, your car, your cans, these are all a part of secondary manufacturing where the raw material, such as the ore to make the metal, was then processed into sheets of metal, and those sheets of metal then are used to make the secondary product, the plane, the boat, the train, the can for your sweet corn to go with your fire engine. The industrial products, these go to another factory and can be the starting material for that factory's products. Consumer goods, on the other hand, these are produced using multiple industrial products brought together to make consumer goods such as domestic refrigerators. If you were to go into your kitchen and look at your refrigerator, you will see that it contains plastic, it might contain glass, it contains metals, it contains paints. All of these things are not produced in one factory, but the products of multiple factories are brought together to make the product of the refrigeration unit factory. Canned goods. Well, canned goods contain agricultural products and paper products and the can, which means that different raw materials would have gone in to making these industrial products, which then go to bring all of these items together to give you your can of sweet corn. And again, clothing is another example of a consumer good. So now we've made our products, we have used our products, and we're at the point where our product is no longer useful for the use we had initially purchased it for. So what are our options? We can just toss it in the garbage and it's out of sight, out of mind, or we can consider how can we reduce the impact of our used up product on the environment. Well, there are reuse options. For example, we can take that item, an old t-shirt, an old towel, and we can repurpose it. It can now become a dust rag, a car cleaning rag. We are not changing the structure of it. We're not changing the makeup of it, but we are using it again. And by using it again for a different purpose, we are taking it out of the waste cycle and thereby reducing the impact on the environment. By using it for this secondary purpose, we are also then saving ourselves from having to buy a cleaning rag. So on the one hand, it is more economical. We're not buying something else for this second purpose. On the second, we are preventing this from going into the environment as early. And we are also reducing the energy required because it's already been made. So the energy input, we didn't need to purchase a new dust rag, cleaning rag. So energy wasn't expended in making that new rag specifically for us. The materials that are locked in that old piece of cloth are still there. Right. So in terms of repurposing, recycling, reusing, this is a sustainable approach, reducing the impact on our materials on the environment. But let's say that we don't have a particular use for our used up product, or we don't even consider it. Well, in that case, our used product is set for disposal. How do we dispose of it? Now, as a consumer, oftentimes what we do is we simply put something in the garbage truck comes, collects it, and takes it away. And as far as we're concerned, it's a done deal. It's gone. However, on the municipal level, what's happening within the wider community? Well, we can consider several different ways of disposing of waste. There's incineration, taking the waste, exposing it to high heat, burning it. There's composting. There's a sanitary landfill. There's sea disposal, underground in case where a deep tunnel or hole is dug and the material is injected down into that, and then it is packed over. And then, here's a novel approach, we could shoot our garbage into space. But each of these approaches to handling waste has to be considered in terms of what is the environmental impact? How does our use of this particular method affect us and the environment? Well, incineration, to start with, can generate waste gas. It can also generate particulates. If you've ever been around an open flame, you'd have noticed that if you stand there too long, you might get ash on you. Well, imagine burning tons of material, that can create tons of particles. And these particles are very fine. They go up in the air and then they're going to settle somewhere. That could be an issue. Now, a benefit of incineration is that you can take very large amounts of waste, solid waste, and when you burn it, incinerate it, you reduce that volume significantly. That means that the volume of waste that you now have to move is going to be much, much smaller than if you just taken all of the domestic garbage and then all of the community garbage and put it on the truck, drove it to the waste area, and dumped it. So incineration has been used as a way to reduce the volume of waste. If waste gases are processed properly and particulates are gathered and sorted or dealt with in a suitable manner, incineration can be an option. Bear in mind, however, that incineration does require significant amount of energy. It requires a well-organized system in order to manage the incineration process. Composting is an option. However, it is only suitable for biodegradable substances. That means substances that can be broken down by the natural environment, by bacteria, by heat, water, and all of these factors combined. If your item or your waste can't be broken down in this way, then composting will not be a suitable approach. Composting also requires you to be able to have only the biodegradable material being used. That means that before you consider composting, the waste has to be separated. And separation of the waste requires, again, organization. Whether it's at the domestic level, the individual household separates the waste into compostable material, non-composting material, and then at the community level, the same thing happens, and at the island level or the city level, then again, separation. So if the waste isn't being separated, composting isn't really an approach. The benefit of composting is that it generates a useful product. You generate rich soil, which can then be fed back into the environment to improve the soil. And that soil can then be used to generate agricultural products, horticultural products. So if composting is done successfully, it's a beneficial way to get rid of biodegradable waste. The sanitary landfill is a commonly used approach in many communities and nations. And the reason for that is that it's very easy. You collect the waste, you put it in a truck or vehicle, you take it to the municipal landfill, you dump it, you take a tractor, you cover that with dirt, and you do it over and over and over again. Now, if it's just a landfill, there are issues. If it's a sanitary landfill and it's been done properly, there should be a layer of separation between the water table, the ground, and the waste that's being put in. It should be managed so that you don't generate gases that are noxious or toxic, and that the waste doesn't become subject to frequent burns. Also, if it's managed properly, there shouldn't be oozing of liquids, waste that are seeping through and contaminating the water table. If it isn't managed properly, then you generate a whole lot of bacteria. You have birds flying in, carrying waste back and forth. You have it poorly secured where people can get in and go into the waste, again, disease issues. You have leaching where substances get into the water table. The other major negative factor to consider for a sanitary landfill is literally land. It takes up space. And the land that is used for the landfill isn't useful for anything else while it's being used as a landfill. Right? And that means that you're taking away from the agricultural potential, you're taking away from the residential potential, and you're using it basically to store waste. The other thing is the amount of waste generated by a community is large and ever increasing. That means that you will continue to have to find ways and places to store and process this solid waste. So solid waste management becomes a serious issue when you're only using a landfill. Even if it is a sanitary landfill, you still have to consider that waste will continue to grow and grow and grow in mass and volume. For some, seed disposal is used either officially or unofficially. Seed disposal carries with it the hazard of affecting the marine environment. You have to consider what is the impact on the marine life. This is particularly an issue for countries like the Bahamas, where a portion of the economic benefit for the communities comes from the marine harvest. Also, when we think about tourism, areas that have tourism and they sell the tranquility, the cleanliness, the marine environment, well, sea disposal again becomes an issue. Do you want to be swimming in waste? No. If you're consuming marine products, do you want to be consuming products that have been consuming waste? So sea disposal is an issue to consider. Even though in some cases it's being done, you have to consider what is the impact on the environment. Is this something that's desirable or advisable? In places where the land goes deep before you hit water, underground disposal of waste is an option that's been taken. Also, for some of the more toxic waste, again, that's been considered. An underground disposal involves digging a tunnel, a hole that goes down very deep, and then packing the waste there. This doesn't take a lot of the surface landmass, but again, you have to consider that what goes down will eventually spread, right? So it may not impact your water table today, but consider what happens if there is an event that then affects the underground stability. Will that waste then become exposed? Will that waste then join the water table? What are the potential impacts? And again, space. There have been discussions, considerations that we could shoot some of our waste into space. What do you think? So, these are some of the considerations to have when we look at the chemical life cycle. How are we going to get our raw materials? How do the raw material processing and extracting affect the environment? What waste is generated? And then we process. How does that affect the environment? And then we get our product. How does using our product affect the environment? And then our product is finished in terms of its useful life. How do we dispose of our product? How does that affect the environment? So from the time we have the raw material to the time we dispose of our used up product, we have to consider what is the impact every single step of the way. And those considerations all come together when we do a chemical life assessment. In the next part of this presentation, you look at the production of aluminium or aluminum from the raw material bauxite. And keep in mind the discussion we've had so far in terms of the various stages of the chemical life cycle and the potential impacts on the environment. You may continue on from this point. Thank you.